My name's Mike Sullivan. I do oral surgery for a living and fly and build planes for fun. Join me on my journey off the beaten path as I build my Rans S-21 Outbound.
Organizing parts for the Fuselage Kit. I'm going to start by doing the tailcone, which is a part of the Fuselage Kit, so separating bolts and nuts and rivets so that they are easy to find. All the blue parts. And different bolts and nuts and washers of different sizes. Master brake cylinder. Seat rails. Here's the parking brake. So anyway, only a few rivets in here. So probably 3,000 or 4,000. Let's find out. 500 in here, 150 in here, 782 in here, and only 998 in here. We're shy of 2,000 people, especially after you add these. Alright. Alright, we are doing the initial tailcone assembly. Here's the text instructions. We've got the parts diagram and all the parts numbers, and the numbers correspond to here. Got our rivets and bolts, and these are all the parts on this list we have here and here. It's like opening Christmas presents. And kind of put them together with this. Here's the part number 0705. KPFU 0705. Okay, that's not on the list. 0728 left is S5 left hand. Number 7 on here. Those two must be for later. So basically, these are going to go together like this, and they're going to start forming the tail of the plane. I don't know if you can visualize that or not, but that's what we're doing.
If you like these videos and you're taking anything away from them, getting any of these tips, let me know about it in the comments. I'd love to hear about it. Also, give me a thumbs up or a thumbs down if that's what you think. I'd like to get at least some feedback. And hit the subscribe button so that you get a notification and you can get back to my channel easily to see more videos in the future.
This is called a tang. We have to drill a hole 1.213 inches from the edge of this hole. So using this instrument, we'll just go ahead and score it. Leaves that nice line on there. So we know where to put it. punch here. And we'll put a little hole punch in there. Then we'll drill our number 40 hole. That will be a wire. I'll show you the completion. That'll be a wire. And it's actually a cotter pin that holds the cable for the tail wheel steering in place. Alright, so we have to make these little bushings out of this piece of pipe here. It's just a piece of aluminum. Looks like a little pipe, but it's not, just a piece of aluminum. So we'll stick it in the vise here. Turn on some CO2. There we go, that'll be one of them. The thing is smoking hot. Cut ourselves another one. Alright, now we'll see if these things have cooled off. They're still a little bit smoky. And we'll finish them up. Make sure we got the right size hole there so the bolt can get through. Get all these rough edges off. This little thing goes in the pulley assembly for the rudder and tail wheel steering. All right, that feels pretty good. Still warm. Sandpaper on the tabletop trick. It actually looks pretty good. Yep. Now we can take them over here to this situation, which is where they end up going. Alright, this one's already fitted up. And they go right in here. Right there. So we have to do the same one over here. This is the cable that goes to the front of the plane. So here's one assembly. The idea is that we didn't replicate this on the other side. Tried to leave these cables kind of tied together so that they wouldn't be up in a knot. Alright, we'll see if we can get our little bushings in here. Should go bolt, then this U joint, no, on the outside, should go bolt, bushing, U joint, bushing, oh, perfect fit. Yeah, that's what I'm talking about. All right. Now we just tighten all these up. So what happens is, these two pedals, or these two cables, go up to the rudder pedals. And this one, the top one, comes through this pulley, goes to the rudder, and the bottom one goes to the tail wheel. And that would be on the right side. Oops. This is the left side. So top one goes back to the rudder, bottom one goes back to the tail wheel, goes down to the tail wheel. All right, onward and upward. These holes in the middle are a bigger size, so those don't get rivets right now. All right, that one's all prepped.
Wow. I mean, we could.
This is the Station 10 Bulkhead assembly, and we're listening to EAA in the background.
There's a failure mode that basically means any single component can fail, right? So the way you kind of approach this, you say, okay, if this box fails, what happens? Is it hazardous? Is it catastrophic? And there's different ratings, different definitions for each of those. It depends on, if you have built for local VFR flying, and you just have one display and one ARs and one radio, and you have a radio failure, what do you do? It just depends on the airspace you're in, and landing at. There's alternatives that work for you, so I can't really give you a definitive answer here, but you got to look at your mission and mitigating the failure cost. So if you're flying IFR, you have one AR, one attitude source, and that fails. Now you're in the clouds, you have no attitude source. Good chance you kill yourself. So that's considered catastrophic. So you want to add a backup attitude source powered by a different bus, and that's why the G5, for example, the V10, the Aspen, they have backup battery systems built into them, so that you do have an attitude source in case your primary fails. Again, going to kind of systems that are upgraded over time, some systems, the backup attitude source can also be used to drive the autopilot if the primary attitude source fails. So there's some really interesting integration that works together. Garmin, for example, when they designed the G5, software and hardware, everything is different, completely different than the software and hardware on the primary display. So you don't have what's called a common mode failure, meaning that if you have the same bug in both of them, it will affect both simultaneously. So it's always good to be aware of the vendor handling it that way, or to use components from the similar vendors. But I think I digress a bit. I can't answer that question directly because there's just too many things to consider to answer that if I understood the question correctly.
Yeah, for sure. Comment here, Robert just wanted to call out that as an EAA member, we have access to use SolidWorks, and we can use that to draw your electrical because electrical is included with it, apparently.
Yeah, no, that's great, and that's a great benefit from being EAA, and the thing is, SolidWorks, there is a learning curve for that, so if you know how to use SolidWorks, super, use it. You don't know how to give it a try, some people they just stay, and for others it's just right, and so there's no one way.
Yeah.
This is circled because we're not supposed to rivet them at this time. We're going to rivet them sometime later in the build. Probably when you attach the
So we don't use solid wire.
some other part of the tailcone.
That I can think of. We do use bus bars, like we mentioned earlier, on the back of or on between the starter and the battery. You can put a bus bar there. But we use any solid core wire. It's just not standard. None of the mil-spec test cell wire is solid core. There may be specific instances where it's needed, but I can't think of any. It's not common, so no, I would not use the solid core wire.
And Charles is wondering, what applications do you recommend shielded wire?
So shielded wire, there's two places that you use it. One is for data buses, so CAN bus, RS-232. There's certainly plenty of aircraft that are, the data buses are wired without shielded wire, and they seem to work fine. And we could go back and forth on that all day, but the standard, especially for certified aircraft, is to use shielded wire for data buses, and that's because they're very low voltage and can be affected by other things around it. Coax cables, for antennas, those are shielded as well. And then the other way, just more standard wire, is some OEMs will recommend the use of shielded wire for power. Strobe lights, for the LED strobe lights, the older high voltage strobe lights, they have a drain wire. It's not really a shield, it's a drain, it's just a single wire. So if the manufacturer says you should use shielded wire for this, I know in Lightspeed, they recommend shielded wire for powering the Lightspeeds. And so if there's some specific implementation like that, you should do it. But as a general rule, it's for data buses. And I do know there's lots of data buses that aren't using shielded wire and work fine too. If you want to do that, you can. It may or may not work as advertised.
Okay, last question. We have 1 minute from James in Scotland. What are the benefits of having 2 EFIS displays?
Hi, James in Scotland. Thanks for staying up a little bit later for us. Yeah, so 2 EFIS displays. So there's several different reasons. One is as a backup display. So if you're flying VFR, there's really no reason for a backup display unless you just want one. Mostly IFR backup display will like here in this picture here, there's a backup display that's a different type than the primary. Now, you can also, in terms of a backup display, and the question's a little unclear.
Enough thread showing.
If you have, say, something like this, you have backup display. You have several different displays. Maybe you